In this lesson, we're looking at the vertex form of a quadratic function. So before we get into that, to review from Unit 3, when we did transformations, we're going to do these three graphs, A, B, and C, and then we'll kind of connect this topic that we have already covered to the new topic for today. So in part A, first I should probably read the directions. We want to graph the parent function with a dashed curve, and then sketch the new function g of x with a solid curve. So in part A, if I start with my parent function, we know that we have a vertex at the origin, 0, 0, and we're just going up 1 over 1, and this is our most basic graph for absolute value of x. All right, now what happens here is this minus 5 tells me we're going to move right 5, and this plus 3 means we're going to move up 3. So if we go right 5 up 3, here's where the vertex moves to, and then in front there's nothing there, so it still opens up and just goes up 1 over 1. In other words, like our slope and direction don't really change. So that's part A. In part B, the parent function, once again, would look something like this. All right, and now the plus 4 means we're moving left 4, and there is basically a plus 0 at the end, so we don't move up or down at all. The 2 means I'm going up 2 over 1 in each direction, so my v is going to be a little bit narrower than the one in part A, and the one that we'd graph for the parent function. All right, in part C, we have inside just an x, so we're not moving right or left at all, and then the minus 1 means we'll move down 1. First, let me sketch with a dashed curve here, once again, the parent function. Okay, now for g of x, we start at 0, negative 1, and then with a negative in front, we now are opening downward. So we go down 1 over 1 in each direction, and we can connect with our solid curve. All right, I will come back to this in a little bit, but to keep going through the notes here, I know there's lots of writing to read through here. This was just reviewing absolute value functions. We know they're shaped like the letter V, and here we're given the general form. Now, since today we're talking about the vertex form of a quadratic function, take a look at what that form looks like down below. So just to review, we've already covered standard form, which is ax squared plus bx plus c. Now we're looking at vertex form. How does this vertex form compare to the absolute value above? So notice they both start with y equals, and then they have an a, and then they have an x minus h, and at the end they have a plus k. So what's different is in the absolute value equations, there's an absolute value symbol. And in the vertex form of a quadratic, instead of absolute value, we have parentheses with a squared. Everything else is identical except for what I just highlighted. So as you can see, from what we had learned in Unit 3 with absolute value equations, the vertex form is a very similar looking form to what we saw there with absolute value. With that said, we have a lot of the same information here as far as when A is positive, the parabola opens upward, just like the absolute value graphs open up, and if A is negative, it will open down. The larger the A value, we'll look at what happened up here when we had a 2. The V got narrower, so the same thing will happen with a parabola. It'll get narrower. H, which is inside the parentheses with the x, will move left and right. And if we see in the parentheses x minus h, that's when it goes to the right. If we see x plus h, that's when it'll go left. And then the k will move up or down. So when we see a plus k, it will move up, and when we see a minus k, it will move down. One other thing when we do get to graphing, which is not until the next lesson, is that we're no longer doing a V. So once you have some points, then you connect it like this, and it's going to be more U-shaped. instead of V-shaped. So it'll be curved instead of like two rays connecting, or the straight segments there. Okay? All right. If we look at our example on the next page, given each equation in vertex form, determine the vertex. We are looking at problems and finding the vertex. Then we're working backwards. We're given a vertex and we're writing the equation in vertex form. So the most important thing here, which wasn't even directly written on the notes on page 1, so I'm going to add that in now, is that our vertex is the H, comma, K. The H is here, the K is here. Now, notice what comes in front of the H in our equation, a minus, and what comes in front of the K, a plus. So when we're looking at a problem, like let's look up here and identify the vertex. The vertex here is 5, 3. When we look at our equation though, what do we see? A minus 5 and a plus 3. So when we see a minus 5, we kind of take the opposite of that. And when we see the plus 3, we keep that one the same. Okay, if we look here, our vertex was at negative 4, 0. Once again, we took the opposite of this and kept this one the same. And here we had a 0, negative 1. So we looked inside the absolute value, we took the opposite, this one we kept the same. So when I'm finding vertex, I like to just think opposite, same. But you have to make sure you're looking at the right two numbers. You're not looking at the A, you're looking at the H and then the K, so the part inside the parenthesis and then the part after it. And if one of those is missing, then you have a 0 in that spot. So if I look here, I have a negative 2, or a minus 2, and then a plus 4. So one opposite of negative 2, which is positive 2, keep that one the same. My vertex is 2, 4 for part A. Here, if I take opposite, I get negative 5, same, negative 2. There's my vertex for part B. Here, if I take opposite, I'm not looking at the negative 8, that's the A value, so the opposite in minus 3 is 3, and then there's a plus 0 at the end, which I keep that one the same. This one, there is no parentheses, so it's like just having the x being squared and that's it. So I start with a 0 and then a 7. So if I go back and highlight what I was using, once again, opposite, same, there it was just the 0 and then the 7. So that's how you identify the vertex when you're given a quadratic function in vertex form. So if we work backwards now, maybe up at the top here, I'll rewrite our general equation, y equals a, x minus h squared plus k. Each of these problems, we're just going to use a of 1. So in other words, we just won't worry about putting a number there in front of the parentheses. And we're just plugging in what's given for the vertex, which is the hk. So if this is h and this is k, I have y equals, and in parentheses, I'm going to take x minus h squared plus k. So this would be y equals x minus 1 squared plus 4. We're doing the exact reverse of what we had done in example 1, where we had the vertex form, found the vertex. Now we're given a vertex and writing it in vertex form, assuming that a is just equal to 1. All right, let's try part B. I have y equals, because I want to write an equation, so I need an equal sign, x minus h, which is minus negative 6, which becomes plus 6 squared, and then plus 9. If I do the same thing on part C, I have y equals x minus 0 squared, which is just x squared, and then a minus 5. And why don't you go ahead and try part D? You can hit pause, write down your answer, and then hit play to check it. So let's see how we did on part D. We'd have y equals x minus 8 squared minus 3. All right, just to think of a couple reminders before we finish here. When you are doing this, one of the most important things is to be careful of your signs, whether there's minus or plus. Also, don't forget the little details like the squared. It seems very minor if you just forget the little exponent up there, but it is extremely important because without the squared, it's not quadratic. And that's what this entire unit is about, quadratic functions. So you need the squared, you need the y equals, all those little details. So this concludes our lesson on vertex form. In the next lesson, or actually the next two lessons, we'll do more with this where we'll be graphing and converting. But this is just to kind of introduce you to vertex form and understand by looking at that equation how to find the vertex and then the reverse of that.